Okay, so today we're going to consider a transformation of the UV plane, and the following is true. We know that the variable u is bounded between 0 and 3. We know the variable v is bounded between 0 and 2. And the transformation t we have says that x equals 2u plus 3v, while y equals u minus v. So our goal is going to be able to figure out um, what this region we have in the UV plane looks like after applying the transformation. So here we are, we've got the transformation u and v, the plane u and v, sorry. U goes out to 3 and v goes up to 2. And so we have this rectangular region here. I'm going to give each side a name, and then we're going to work on it. So I'm going to call this side S1. I'll call this side S2, S3, S4. While I'm at it, I'm just going to, oops, let's leave that. Yeah, let's copy all this just so we have it. Okay, good. So let's start with side S1. What can we say about it? And we just go through one side at a time and see what happens. Well, in side S1, we can say that V was 0, and simultaneously V is 0, and U is staying between 0 and 3. So if we apply these two things and our transformation together, then here's what we get. So we do these things, we get x is going to equal 2u plus, and really it's going to be 3 times v, or 3 times 0. So x equals 2u, which also means that u equals a half x. That's what that tells us. So keep that in mind. And then what we can do is we can plug this up here, and we can get y equals 1 half x. So that's great. That's actually not so bad. We just need a domain for this. Like, when will we be graphing this line, y equals half x, which is really easy, good thing to graph? Well, what can we say? When we start with 0 is less than or equal to u is less than or equal to 3. And this is not going to be immediately obvious, but you'll see why I'm doing it in a minute. I know x is 2u, so I'm going to multiply this whole thing by 2, right? So I'll get 2 times 0 is 0. And this is 2u, and that's less than or equal to 6, because 2 times 3 is 6. But 2u equals x, so we can say that 0 is less than or equal to x is less than or equal to 6. So the thing I'm going to do is make a new page and keep track of what we have so far. So what we know right now is that we have the equation y equals 1 half x, and that's going to be on the domain 0 less than or equal to x less than or equal to 6. Okay, so far, so good. So now what we're going to do is we've got to start over again and look at a different side. So let's get a new page. Let's paste what we had. There we are. Let's not forget the transformation. The transformation does this. X equals 2u plus 3v. Y equals u minus v. And let's go for side 2. So what can we say on side 2? This was side 2, just in case you forgot. Well, you can say that u always equals 3, and you can say that v is less than or equal to 2, but greater than or equal to 0. So let's take that u equals 3 and plug it into both of these things and see what we get. Well, we would get x equals 6 plus 3v, right? Just put the 3 in here. 2 times 3 is 6. And then if we put the 3 in the bottom, we get y equals 3 minus v. So let's take this. We can start moving things around, plugging things in. Let's solve this for v. So we would get x minus 6 equals 3v, or 1/3 x minus 2 equals v. And that can go into the other equation here. And so you get y equals 3 minus 1/3 of x minus 2. And that ends up telling us, implying that y equals 5 minus 1/3 x. Okay, great. You're going to need a domain restriction here. What do we know? We know that v is stuck between 0 and 2. And somehow using that, you'd like to get to know something about x. So here's the equation that relates x and v. So we're going to use these two things together somehow. So what I'm going to do is I'm going to take that 0 is less than or equal to v is less than or equal to 2. And I'm going to try and build this thing. So I'm going to multiply it by 3. 3 times 0 is 0. Less than or equal to 3v. Less than or equal to 3 times 2 is 6. It's not bad. Now I'm going to have to add 6 here because this has got a plus 6 that I need to deal with. So if I add 6 to this equation, this inequality I should say, 0 plus 6 everywhere, then I get 6 is less than or equal to 6 plus 3v, which is less than or equal to 12, but that's equal to x right here. So I can finally say the following. I can say that 6 is less than or equal to x is less than or equal to 12. So I've got this domain with this line. So I'm going to go find that page where I'm keeping track of everything and write down this next equation. So we have y equals 5 minus 1/3 x. And that's going to be true for the domain 6 is less than or equal to x is less than or equal to 12. So you can call this first one like side 1 prime. This is side 2 prime. Okay, we got a few more to get, 2 more sides to go, so let's go do that. Let's draw, here's our picture again. Gonna lose track of things. Here's our transformation again, just in case we forgot. So t is x equals 3, oops, that's not correct, sorry, 2u plus 3v, y is equal to u minus v. Okay, and we're going to look at side 3. So in case you forgot, this is side 3 here up top. So what can we say is true? All along side 3, we have v equals 2, and then u is bound between 0 and 3. Okay, so let's plug these things in. So we would have x equals 2u plus 6. That's because we're putting this 2 here into this v over there, this v. And the second equation becomes, this one here becomes y equals u minus 2, right? Because we're going to put that v equals 2 in there also. Okay, so from out of these two things, we should be able to get an equation that has x and y in it. So I think I'll take this one and solve. I'll take this one and solve it for u. So if we did that, we'd have x minus 6 equals 2u, and then divide by 2, I'd have 1/2 x minus 3 equals u. And let's put that up in here. We get y equals 1/3 x. It's going to be minus 3 and then minus 2, or y equals 1/3 x minus 5. Okay, so that's promising. We need a domain now, and that's what we need to do. So I'm going to look at, I want to get a domain for x. I'm going to look at this equation and this equation together, and I'm going to try and change things. So I'm going to multiply this one by 2. This will become 0 is less than or equal to 2u is less than or equal to 6. And then I'm going to add the 6 that's over here onto both of them. So plus 6 plus 6 plus 6, and I get 6 is less than or equal to 2u plus 6, which is less than or equal to 12. But this thing in the middle here, this thing is this thing, which means it really equals x. So you end up with 6 is less than or equal to x is less than or equal to 12. So that's our next equation that we can keep track of. let's go onto that page and make a note of it. So now we have, well, let's make sure I didn't make any errors. I think I wrote 1/3 there, but I have a small error. Just realized something. I have a 1/2 here, and then when I plugged it in, somehow I wrote 1/3. So this should have been 1/2. If you notice that error, I'm sorry. This should have been 1/2. So that's the one subtle difference. Okay. So back over here, I need to write down that y equals 1/2 x minus 5, and the domain is the same as the one above. I want to call this side S3 prime. Okay, great. We've got one side to go. So here we go. Just in case we're losing track of our pictures again. There it is. So we're finally up to side S4. That's what we're dealing with. What can we say about that side? Well, the transformation again, just so we don't lose track. X equals 2u plus 3v. Y equals u minus v. And then over here, what can we say? We can say that u is always 0. We can say that v is restricted between 0 and 2. So if we take that and plug that in here and here, we get x equals 3v. The second equation becomes y equals negative v. Let's see, this equation really means 1/3 x equals v. Plug that in here and you get y equals negative 1/3. Well, yeah, negative 1/3 x. Okay, so that's pretty good. We need a domain now for this. So what can we say here? Well, I'm going to look at, I would line restrict x. I'm noticing x is 3v, and then I'm going to take this inequality, and together, I'm going to multiply this all by 3. I'm going to get 0 is less than or equal to 3v, which is less than or equal to 6. But we already know that 3v is really x. We can see that right there. So what we end up getting is 0 is less than or equal to x is less than or equal to 6 with this equation. All right, and that's our fourth side. Let's go to another page there and make a note of it. So y equals negative 1/3 x. And domain 0 is less than or equal to x is less than or equal to 6. So I'm going to call this side S4 prime. And we should notice a couple of things. These lines appear to be forming a parallelogram. Well, how would I notice that? Well, I noticed that these two lines have a slope of 1/2, and these two lines have a slope of negative 1/3. So your opposite sides are parallel in this case. Okay, so the last thing I'd like to do is create a graph of this picture of these equations and see what we get. So let's see what this thing looks like in the xy plane. So I'm going to worry about this first one here. Y equals 1/2 x from 0 to 6. So that's not so bad. So here we go. Draw an xy axis. And y equals 1/2 x. That's going to start at 0, 0. It's going to wind up to 0. It's going to go out to 6. I'm going to care about the number 12 at some point. But it's only going to get up to a height of about 3 because it's 1/2 x. So not about 3. There you go. So this is the y equals 1/2 x. Okay. Our next equation is this one here. Let's use a different color. We'll use, I guess, purple for that. So that's y equals 5 minus 1/3 x. Think about it. If I plug 6 in here, right? So 5 minus 1/3 x. 1/3 of 6 is 2, and 5 minus 2 is 3. So that's really good. It actually goes right through the point 6 comma 3. So that meets up where the old one left off. And if we plug 12 in there, which is a good thing to consider, 1/3 of 12 is 5, and then 5, I'm sorry, 1/3 of 12 is 4, and then 5 minus 4 is 1. So this goes out to the point 12 comma 1. So maybe something like this is what it's going to look like. And that's the line y equals 5 minus 1/3 x. Okay, let's go to our next side. Use a different color. Let's use green now. So this is going to be 1/2 x minus 5. Well, if you plug 6 in there, Half of 6 is 3, minus 5 is negative 2. So it goes through the point 6, negative 2. So that's probably about here. This is the point 6 comma negative 2. I'd like it to go through this point over here. I want it to go through the point 12, 1. Let's see if that happens. If I go over here and I plug the point 12 in, half of 12 is 6. Oh, wow, minus 5 is 1, so it does do what I want it to do. So there you go. There's that side. And then the last line is just the line y equals negative a third x. And if you plug in 0, you get 0. You plug in 6, negative a third of 6 is negative 2. And sure enough, let's pick a different color for that. Let's use, I don't know, let's use blue. Let's use blue for this last one. It does go through the 2 points we want. And there you have it. So that's y equals negative a third x. So sure enough, this is our region that our original nice rectangular region got mapped into. So as we head towards the Jacobian, what you're going to realize is you're going to get not nice looking rectangular, or in this case, a parallelogram-like region. And what we want to do is take it and transform it into a region where the limits of integration would be like this. And think about setting up this integral. In this case, let's go to a new page here. Let's just think about this for a minute. In this picture, your double integral is going to look like this. Double integral, 0 to 2, 0 to 3, du dv. It's very nice limits of integration. Whatever the function of u and v is in here, that's not going to be bad. However, in this case, if you're going to try and do a double integral, dy dx, you have some issues. One is y sometimes is between this yellow and this black and blue curve, and other times it's between the purple and the green curve. So you do 2 integrals to set it up. So you're beginning to see now why we might want to transform regions. Thanks for watching.